Welcome to the Alpha Trading and Consulting's online training program. Today we're going to answer the question, what is alpha risk and p-value? A very important question to answer. Remember, Alpha has been preparing students for ASQ certification exams for over 20 years, and we are very good at it. We have become very good at it over time. So I hope you'll consider us should you ever desire to get an ASQ certification. All right, we're going to talk today about p-value and alpha risk. And it's all about performing inference studies, which is all about the question, did it make a difference? Okay, and it's important to remember in this alpha risk and p-value world, the world of inference studies and hypothesis tests, they use those interchangeably, inference tests and hypothesis tests. In this world, this is the statement you need to remember. This is where everyone gets messed up on the alpha risk and p-value. It's all about the statement, yes, it did make a difference. What are we talking about? Well, let's use our example we've used in various other lectures, and that is the distribution of original tumor growth rate prior to treatment. No treatment, you work in a lab and you've been collecting this data for years. And so on average, this is the growth rate of the tumor. Some people have faster growth rates over here. Some people have slower growth rates. But this is the nature of the variability of tumor growth rates. Okay? And that's the red curve. Now, we decided to create a treatment to try to reduce the growth rate of these tumors. So we implement the treatment and we collect a sample or data from that sample treatment. And there you have, notice there's a difference in the average in this case. Now, this red distribution, the population distribution if you will, notice it overlaps the average of the treatment distribution. Okay? And what is this, this overlap here? Well, it's the probability that you're wrong when you say, yes, the treatment did make a difference. So again, this overlap of this population distribution that overlaps the average of the treatment sample, that is the probability that you're wrong when you say, yes, it did make a difference. The probability that you're wrong. So if this was 10% of this distribution, you'd say there's a 10% chance I'm incorrect when I say, yes, it did make a difference. So that's what that is. Okay, let's go to the next slide. What is the p-value? Remember, that was the question we're answering. What is the p-value and alpha risk? Well, here's the p-value. P-value is that overlap. So probability that you are wrong when you say, yes, the treatment did make a difference. The probability that you're wrong is referred to as the p-value. So if the p-value says 0.4, that means that there's a 40% chance that you're wrong when you say, yes, it did make a difference. Or if the p-value is 0.03, that means there's a 3% chance that you're wrong when you say, yes, it did make a difference. This is the p-value. And ultimately, it's that overlap that the population distribution goes beyond the treatment sample distribution. Okay? So hopefully that makes sense. Now let's go and talk about alpha risk. What is alpha risk? By the way, that's the symbol of alpha right there, in case you didn't know. Alpha risk is the risk you're willing to take when you say, yes, it did make a difference. So when you make the statement, remember, you need to remember this statement, yes, it did make a difference. When you make that statement, there's always a risk involved. Why? I don't draw it this way, but these curves, these normal distributions, go on for infinity. They never really touch this horizontal line. Of course, I can't draw them that way because I don't have a big enough piece of paper to go out there. So I just draw them like this, but just so you know, they go on forever, which means what? You're always going to have overlap. You're always going to have p-value, which means you're always taking a risk that you could be wrong. Wrong when what? When you make the statement, yes, it did make a difference. So alpha risk is the risk you are willing to take. So if I say, okay, I'm going to do this study and I'm willing to take a 5% risk that I'm wrong when I say, yes, it did make a difference. Okay, a 5% risk. That's the most common alpha risk, by the way, is 5%. Some people do less. Sometimes you may do more. But the most standard one by far is 5%. So again, alpha risk is the risk you're willing to take when you say, yes, it did make a difference. The most common used alpha risk is 5%. Remember, now we have alpha risk, the risk we're willing to take, and the p-value, which is the actual risk you take. So again, alpha risk, the risk I'm willing to take, p-value, the risk you are actually taking. So if your p-value is greater than your alpha risk, remember this, alpha risk is the risk you're willing to take, and p-value is the actual risk. So if actual risk is higher than 5%, for example, then you would say it's statistically insignificant. Why? Because I'm not willing to take more than 5%, so if the p-value is over 5%, it's statistically insignificant. Okay, let's do the other way. Let's say the p-value, or the actual risk you're taking when you make the statement, yes, it did make a difference, is less than 5%. Let's say 1%. Okay, and your alpha risk is 5%, so your p-value is less than your alpha risk. I'm willing to take a 5% risk, but there's only a 1% risk here. Therefore, it is statistically significant. So let me review. When the p-value is less than the alpha risk, it is statistically significant. When the p-value is greater than the alpha risk, it is statistically insignificant because you're not willing to take that much risk. In summary, alpha risk is the risk I'm willing to take when answering the question, did it make it? Yes, when making the statement, yes, it did make a difference. P-value is the actual risk. Alpha risk is the risk you're willing to take. Anyway, hopefully that helped. Please keep us in mind should you ever need an ASQ certification preparation class. Thank you, and have a great day. Goodbye.